Good morning friends, I welcome you all for my YouTube channel. Last class, previous many sessions we have discussed about many things about matrices, right? So in previous session we have started inverse using elementary transformations and solved a couple of examples. I have given 2 examples as homework also for you people to try by yourself. In that first one was easy and some of the comments I got that it is second one is becoming more and more difficult. It is not possible to solve. So one thing I want to make clear is, first you need to convert all the elements below diagonal. All the elements below diagonal as 0. Alright. So below diagonal, whatever elements are there, the lower triangle elements, they should be converted into 0. And you should also take care that A11 is always 1. A11 should always be 1. Then only it will be possible for us to solve. If A11 is not 1, you change it. Right? If it is 1, then you proceed for lower triangular elements to convert them as 0 for any problem. Once they are finished, then diagonal elements should be 1, then upper triangular elements should be 0. If we are able to do that thing, then definitely we will get the inverse. Right? So you try that one with this hint. If it is not possible, then definitely I will give the answer in the next session. Okay? So now coming to today's session, we'll start up with exercise 3.4. Here they have asked to find the inverse using elementary transformation if exists. What is the meaning of if exists? That means each and every matrix, it is not compulsory that there should be an inverse. It is not compulsory that there should, each and every matrix should have an inverse. So what they are telling is, if inverse exists for this matrix, then you find out. Right? So we have different methods to find out the inverse. Right? So when we go to determinant, then I will tell you how many ways are there. In different way, how can we find out the inverse of any matrices. Right? For here we are using only elementary transformation to get the inverse. Okay? So let us start with these problems. First one, let us consider it as A. You can give any letter. 1, -1, 2, 3. Okay. We know that A can be written as I into A. A can be written as I into A. So what it is? 1, -1, 2, 3. I is what? 1, 0, 0, 1. A as it is. Now we have 1 here, so no problem. We can proceed to convert this 2 as 0. How to make this 2 as 0? I need to subtract 2. How I can subtract 2? So using row 1. So what will be my transformation? Row 2 changes to row 2 minus 2 row 1. So what will happen? 1 minus 1 will remain as it is first row. Second row, according to this formula, what is row 2 value here? 2 minus 2 times of row 1, that is 1. Let us write this here. And what is this one? 3 minus 2 times of minus 1. This is equal to 1, 0 as it is. 0 minus 2 times of R1, that is 1. And here 1 minus 2 times of R1, that is 0 into A. So what will I get here? 1 minus 1, 2 minus 2 is 0. Minus of minus plus, so 3 plus 2 is 5 is equal to 1, 0. 0 minus 2 is minus 2 and 1 minus 2 into 0 is 1 into A. So we have converted this into 0. Now we need to convert this as 1. So I can write R2 changes to 1 by 5 R2. So what happens? If I apply this, 1 minus 1 as it is, then 0 by 5 is 0, 5 by 5 is 1, 1 0 as it is. This will become minus 2 by 5, this will become 1 by 5 into A. Now what remained is this one, minus 1, that has to be converted as 0. So if I add row 1 and row 2, I will get that as 0. We got this as 0. So R1 changes to R1 plus R2. So what happens here? 1 plus 0 is 1, minus 1 plus 1 is 0. This is 0 and this is 1. And what will be R1 plus R2? 1 minus 2 by 5. 1 minus 2 by 5 is, LCM if I take 5 into 1 is 5, 5 minus 2 by 5, that is 3 by 5. So it will be 3 by 5, 0 plus 1 by 5 is 1 by 5, minus 2 by 5 and 1 by 5 into A. So I can write A inverse as equal to 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. So we have to proceed this one till we get the identity matrix on the left hand side. So this is how we need to proceed with this. So A inverse will be 3 by 5, 1 by 5, right? Minus 2 by 5 and 1 by 5. I hope this one is clear. Let us move on to second one. So A can be written as I into A now. Here I am having 2. I need to make this as 1 in order to get the convenient simplifications. To make the simplification more convenient, I need to make this 2 as 1. That is my first and foremost step. Then you have to proceed with the lower triangular elements. So how to make this as 1? I can apply R1 changes to R1 minus R2. R1 changes to R1 minus R2. So what happens then? 2 minus 1, 1 minus 1, 1 and 1 as it is, will be equal to 1 minus 0, 0 minus 1. Okay. Now 2 minus 1 is 1, 1 minus 1 is 0, 1, 1 as it is, 1 minus 1, 0, 1 as it is. Okay. So this is A is equal to I into A. We have simplified. So we got 1 here. Now I need to make this one as 0. How to make that one as 0? R2 changes to R2 minus R1. Then what happens? R1 remains as it is. R2 minus R1. 1 minus 1. This is 1 minus 0. Here also R1 remains as it is. Then 0 minus 1. 1 minus of minus 1. A. Okay. One, 0. What is this? This becomes 0. This is 1. Okay. 1 minus 1 minus 1 then 2 times of A. So therefore I can write A inverse as 1 minus 1 minus 1 2. So this is A inverse. This way we need to proceed till we get LHS as identity matrix. But once you get this identity matrix, right, so this will be our A inverse. That is, of course, there is no doubt in that, right? But the problem here is if you go wrong with any of this step, right, so in spite of getting here, you may not get the correct value, right? If you make any mistake, then there will be difference. You will get a different matrix which is not A inverse. So how to verify whatever you got is right? Whatever you got is right. How to verify that one? So I will tell you how to verify. Okay, how to verify that one. So we know the standard result A into A inverse should be equal to I. A into A inverse should be equal to what? I. We have A here, we got A inverse, right? So A into A inverse, if I do, what will be the value? A is what? 2, 1, 1, 1. A inverse is 1, minus 1, minus 1, 2. Okay. Multiply this. 2 into 1 is 2. 1 into minus 1, minus 1. 2 into minus 1, minus 2. 1 into 2, plus 2. 1 into 1, 1. 1 into minus 1, minus 1. 1 into minus 1, minus 1. 1 into 2, plus 2. 2 minus 1, 1. This is 0, this is 0, this is 1, which is nothing but identity matrix. So if you get that identity matrix, then only it is verified, right? Then only it is you can surely tell that whatever you have calculated is right. Same thing is here also, right? A into A inverse. What we get here? A is 1, minus 1, 2, 3. What is A inverse? 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. So 1 into 3 by 5, 3 by 5, minus 1 into minus 2 by 5, plus 2 by 5. Okay. This is plus 2 by 5. Next, 1 into 1 by 5. That is 1 by 5. Minus 1 into 1 by 5. Minus 1 by 5. 2 into 3 by 5. 2 into 3 is 6. 6 by 5. 3 into minus 2 by 5. Minus 6 by 5. Now 2 into 1 by 5. 2 by 5. 3 into 1 by 5. Plus 3 by 5. So what we will get here? 3 by 5 plus 2 by 5. 3 plus 2 is 5. 5 by 5 is 1. 1 minus 1 by 5, 0. 6 minus 6 by 5, 0. 2 by 5 plus 3 by 5. 2 plus 3 is 5. 5 by 5 is 1. This is nothing but identity matrix. Right? So when after getting inverse, if you multiply it with A, right? So A into A inverse should lead you to I. Then only your calculated A inverse is correct. Is that clear? So now pause this video. Take down the problems. Okay friends, I hope the problems are clear. First and second problem, also the verification process also clear, I hope. So let's start with the third one. So here also we need to find the inverse. Okay. Here let us consider A as equal to, once again, 1, 3, 2, 7. A is written as I into A. Okay, so that is 1, 3, 2, 7 is equal to I is 1001 into A. Now let us check first A11. It is 1, so no need to do any simplification here. Now let's come to lower triangular elements. Which is the lower triangular element here? Only 2. So this has to be converted into 0. So for that we can apply the transformation R2 changes to R2 minus 2 times R1. So if I apply this, what will I get? 1, 3. R2 will change according to this formula. So R2 minus 2R1. R2 is 2 minus 2 times of R1 here is 1. And here what is the value of R2? 7 minus 2 times of what is R1? 3. This is equal to 1, 0. R2 value here is 0 minus 2 times of R1 is what? 1. And here it is R2 value is 1 minus 2 times of R1 is 0 into A. Right? So if I simplify, what I will get? 1, 3, 2 minus 2 into 1 is 0. 7 minus 2 into 3. What is 2 into 3? 6. Right? 7 minus 6 is 1. Will be equal to 1, 0 as it is. 0 minus 2 into 1. 2 into 1 is 1. Sorry, 2 into 1 is 2. 0 minus 2 is minus 2. And this is 1. Because 2 into 0 is 0. So 1 minus 0 is 1 into A. Now I made this as 0 and diagonal element is 1. So the only thing left out is 3. This should be made as 0. So that can be made by transformation. R1 changes to R1 minus 3R2. R1 changes to R1 minus 3R2. So what happens here? 1 minus 3 into 0. R1 here is 1 minus 3 into R2 is what? 0. Here R1 is what? 3 minus 3 into 1 and here 0, 1 as it is will be equal to R1 here is 1 minus 3 into R2 is minus 2. Okay, and here R1 is 0 minus 3 into 1. And here minus 2, 1 as it is, A as it is. Right, so this will be giving me the value 1 minus 3 into 0 is 1, 3 minus 3 into 1, 3 into 1 is 3, 3 minus 3 is 0, this is 0 as it is and 1 as it is equal to minus 3 minus 2. What is this? 1 minus 3 into minus 2 is there. Minus 3 into minus 2 is plus 6. Right? Minus 3 into minus 2 is what? Plus 6. So 1 minus 6 will be what? Sorry, 1 plus 6. Minus 3 into minus 2 is plus 6. 1 plus 6 will be 7. Right? 0 minus 3 into 1. 3 into 1 is 3. 0 minus 3 is minus 3. And minus 2 here and 1 here into A. Right? So we got I is equal to something into A. So that will resemble to A into A inverse is equal to I. So what is A inverse? This particular matrix. A inverse will be 7 minus 3 minus 2 and 1. So I hope this thing is clear. Alright. So we should proceed as I said up to we get the value of identity matrix on the left hand side. Let's try this one. Here also let A is equal to 2, 3, 5, 7. Right? We know that A can be written as I into A. That is 2, 3, 5, 7 can be written as 1001 into A. Right? A can be written as I into A. Alright? So here observe A11 is not 1. We should get 1 here. So how to get that one? It can be obtained. R1 changes to R2 minus 2 times of R1. R1 will change to R2 minus 2 times of R1. Then what happens? R2 is what here? 5 minus 2 times of what is R1? 2. So R1 is changing according to R2 minus 2R1. So according to this, R1 will be what? R2 minus 2R1. R2 here is 5 minus 2 into what is R1? 2. Here also what is R2? 7 minus 2 times of what is R1? 3. Okay. 5, 7 as it is. Here also what is R2? 0 minus 2 times of what is R1? 1. And this one R2 is 1 minus 2 times of R1. 2 times of 0. Right? 0, 1 as it is. A as it is. Is that clear? So next, what will be the simplification of this? 5 minus 2 into 2. What is 2 into 2? 4. 5 minus 4 is 1. 7 minus 2 into 3. What is 2 into 3? 6. So 7 minus 6 is 1. 5 and 7 as it is. 0 minus 2 into 1. 2 into 1 is 2. So 0 minus 2 is minus 2. 1 minus 2 into 0. 2 into 0 is 0. So 1 minus 0 is 1. 0, 1 as it is and A as it is. Okay. So now we got 1 here. Now we can proceed with lower triangular elements. So how to make this as 0? Simple. R2 will change to R2 minus 2 times R1. R2 will change to R2 minus 2 times of R1. So R1 will be unaffected. 1 and 1 as it is. R2 is what? R2 minus 2 times of R1. What is R2 here? 5 minus 2 times of what is R1? 1. Is that clear? 5 minus 2 into R1. Here R2 is what? 7 minus 2 times of R1 is what? 1. Will be equal to minus 2 and 1. Here R2 is 0 minus 2 times of R1 is minus 2 and here R2 is 1 minus 2 times of 1. I hope this is clear and A will come as it is. Now this can be written as 1, 1, 5 into minus 2, sorry 5 minus 2 into 1, 2 into 1 is what? 2. So 5 minus 2 is, so what we are getting? Sorry, wait, this is not there. So sorry for that. So here we should apply R2 changes to, we should get 0. R2 minus 5 times of R1. We should apply R2 minus 5 times of R1. So 1 as it is. R2 is what? 5 times of R1. Here R2 is 7 minus 5 times of R1. And here also same thing, minus 2 and 1 as it is. R2 here is 0 minus 5 times of minus 2, and here R2 is 1 minus 5 times of 1, and A as it is. Right? So this will give us 1 as it is. 5 minus 5 into 1. 5 into 1 is what? 5. 5 minus 5 is 0. 7 minus 5 into 1. 5 into 1 is 5. 7 minus 5 is 2. So minus 5 into 2. Minus 5 into minus 2 is what? Plus 10. 0 plus 10 is 10. Right? 1 minus 5 into 1. 5 into 1 is 5. 1 minus 5 is minus 4 into A as it is. Now we got 0 here. So we should get this value as 1. We should get this value as 1. Why? Because diagonal should be 1. How to get this one? R2 changes to 1 upon 2 R2. R2 will change as 1 upon 2 R2. So 1, 1, 0, then 1 upon 2 into 2. That is, 1 upon 2 into 2 is nothing but 2 by 2. 1 minus 2, 1. 10 divided by 2 is 5. This will be minus 2. Multiplying by 1 by 2 or dividing by 2. Both are one and the same. Right? So we will get this one. So we got this identity elements are also 0. Only thing remaining is this one. So this also should be converted to 0. Identity element we got it as 1. Now this has to be converted as 0. Right? Diagonal elements we got as 1. And this if we convert as 0, then we will get the identity matrix. Okay. So for that we can apply R1 changes to R1 minus R2. So what we will get here? 1 minus 0 is 1. 1 minus 1 is 0. 0, 1 is equal to minus 2 minus 5. Minus 7. 1 minus of minus 2. That is plus 2. That will be 3. Then 5 minus 2 into A. So we got A into A inverse is equal to I. So that is I is equal to some value into A inverse. So that value, some value into A. So that value will be A inverse. Right? Therefore, A inverse is equal to minus 7, 3, 5, minus 2. Minus 7, 3, 5 and minus 2. Okay. So for this both problems you can verify A into A inverse. Definitely you will get it as A. Right. So for your purpose you can verify it. Definitely you will get it as A. Now pause this video and take the notes down. So friends, I hope you understood the previous problems. Now what you need to do is, next 4 problems, they're also for the 2 cross 2, right? 5th, 6th, 7th and 8th. So I written down them here. So this is of the exercise, the 3.4 only, 5th, 6th, 7th, 8th. So you try them by yourself and let me know what is the answer you are getting. And don't forget to verify your answers. A into A inverse should be equal to I. So verify it. If it is getting, if it is coming to be identity matrix, then there is no need, right? So that answer will be definitely right, because we know that for each and every matrix there is only one inverse. So if that condition is being satisfied, then whatever you have calculated, that is exactly correct. If that condition is not being satisfied, then whatever you have calculated is not correct. Okay, so try this by yourself at your home and let me know the answers what you get. So with this we'll stop the session here. Right? So from 9th problem onwards, we'll continue in the upcoming session. So we'll wind up the session here. Thank you.